Question 16. Why compute nodes and the storage nodes are same? Answer. Compute nodes are logical processing units. Storage nodes are physical storage units. Nodes both are running in the same node because of data locality issue. As a result, Hadoop minimizes the data network wastage and allows to process quickly. Question 17. What is difference between map side join and reduce side join? Or when we goes to map side join and reduce join? Answer. Join multiple tables in map side called map side join. Please note map side join should has strict format and sorted properly. If data set is smaller tables goes through reducer phrase. Data should partition properly. Join the multiple tables in reducer side called reduce side join. If you have large amount of data tables planning to join both tables, one table is large amount of rows and columns, another one has few numbers of tables only and goes through reduce side join. It's the best way to join the multiple tables. Question 18. What is output committer? Answer. Output committer describes the commit of MapReduce task file. Output committer is the default available class available for output committer in MapReduce. It performs the following operations: create temporary output directory for the job during initialization. Then it cleans the job as in removes temporary output directory post job completion. Sets up the task temporary output. Identifies whether a task needs commit. The commit is applied if required. Job setup, job cleanup and task cleanup are important tasks during output commit. Question 19. When we are goes to combiner, why it is recommendable? Answer. Mapper and reducers are independent, they don't talk each other. When the functions that are commutative AB equals BA and associative ABC equals ABC, we goes to combiner to optimize the MapReduce process. Many MapReduce jobs are limited by the bandwidth, so by default Hadoop framework minimizes the data bandwidth network wastage. To achieve its goal, MapReduce allows user-defined combiner function to run on the map output. It's an MapReduce optimization technique, but it's optional. Question 20. What is Partitioner and its usage? Answer. Partitioner is yet another important phase that controls the partitioning of the intermediate MapReduce output keys using a hash function. The process of partitioning determines in what reducer a key value pair of the map output is sent. The number of partitions is equal to the total number of reduced jobs for the process. Hash partitioner is the default class available in Hadoop, which implements the following function: .int get partition k key v value int number reduced tasks. The function returns the partition number using the number reduced tasks is the number of fixed reducers. Question 21. What is combiner? Answer. It's a logical aggregation of key and value pair produced by mapper. It reduces a lot amount of duplicated data transfer between nodes, so eventually optimize the job performance. The framework decides whether combiner runs zero or multiple times. It's not suitable where mean function occurs. Question 22. What is partition? Answer. After combiner and intermediate map output, the partitioner controls the keys after sort and shuffle. Partitioner divides the intermediate data according to the number of reducers so that all the data in a single partition gets executed by a single reducer. It means each partition can executed by only a single reducer. If you call reducer automatically, partition called in reducer by automatically. Question 23. What is setup and cleanup methods? Answer. If you don't know what is starting and ending point / lines, it's much difficult to solve those problems. Setup and cleanup can resolve it. N number of blocks. By default, one mapper called to each split. Each split has one start and cleanup methods. N number of methods. Number of lines. Setup is initialize job resources. The purpose of cleanup is close the job resources. Map is process the data. Once last map is completed, cleanup is initialized. It improves the data transfer performance. All these block size comparison can do in reducer as well. If you have any key and value, compare one key value to another key value, use it. If you compare record level, use these setup and cleanup. It open once and process many times and close once, so it save a lot of network wastage during process. Question 24. What are the important steps when you are partitioning table? Answer. Don't over-partition the data with too small partitions. It's overhead to the name node. If dynamic partition, at least one static partition should exist and set to strict mode by using given commands. Set hive.exec.dynamic.partition equals true. Set hive.exec.dynamic.partition.mode equals non-strict. First load data into non-partition table, then load such data into partition table. table. It's not possible to load data from local to partition table. Insert overwrite table _ name partition year select from non-partition table. Question 25. Can you elaborate MapReduce job architecture? Answer. First, Hadoop programmer submit MapReduce program to job client. Job client requests the job tracker to get job ID. Job tracker provide job ID. It's in the form of job _ Hadoop started time _00001. Its unique ID. Once job client receive job ID, copy the job resources job XML job.jar to file system HDFS and submit job to job tracker. Job tracker initiates job and schedule the job based on configuration. Job split the input splits and submits to HDFS. Task tracker retrieves the job resources from HDFS and launch child JVM. In this child JVM, run the map and reduce tasks and notify to the job tracker the job status. Question 26. Why Tasktracker launch child JVM? Answer. Most frequently, Hadoop developer mistakenly submit wrong jobs or having bugs. If Tasktracker use existent JVM, it may interrupt the main JVM, so other tasks may influenced. Whereas child JVM, if it's trying to damage existent resources, Tasktracker kill that child JVM and retry or relaunch new child JVM. Question 27. What is setup and cleanup methods? Answer. If you don't know what is starting and ending point / lines, it's much difficult to solve those problems. Setup and cleanup can resolve it. N number of blocks. By default, one mapper call to each split. Each split has one start and cleanup methods. N number of methods. Number of lines. Setup is initializing job resources. The purpose of cleanup is close the job resources. Map is process the data. Once last map is completed, cleanup is initialized. It improves the data transfer performance. All these block size comparison can do in Reducer as well. If you have any key and value, compare one key value to another key value, use it. If you compare record level, use these setup and cleanup. It open once and process many times and close once. So it save a lot of network wastage during process. Question 28. What is speculative execution? Answer. Hadoop run the process in commodity hardware, so it's possible to fail. The systems also has low memory, so if system failed, process also failed. It's not recommendable. Speculative execution is a process performance optimization technique. Computation / log distribute to the multiple systems and execute which system execute quickly. By default, this value is true. Now even the system crashed, not a problem. Framework chooses logic from other systems. A. Logic distributed on A, B, C, D systems completed within a time. System A, System B, System C, System D systems executed 10 minutes, 8 minutes, 9 minutes, 12 minutes simultaneously. So consider System B and kill remaining system processes. Framework take care to kill the other system process. Question 29. What is input split? Answer. A chunk of data processed by a single mapper called input split. In other words, logical chunk of data which processed by a single mapper called input split. By default, input split equals block size. Question 30. Why Hadoop framework reads a file parallel? Why not sequential? Answer. To retrieve data faster, Hadoop reads data parallel. The main reason it can access data faster, while writes in sequence but not parallel. The main reason it might result one node can be overwritten by other, and where the second node parallel processing is independent, so there is no relation between two nodes. If writes data in parallel, it's not possible where the next chunk of data has, for example, 100 MB data write parallel, 64 MB one block, another block 36. If data writes parallel, first block doesn't know where the remaining data, so Hadoop reads parallel and writes sequentially.